Hello all, I am GTS Funny and I am a PhD student in Computer Science, University of Bristol. Today, I'll explain the context, theme and approach of my research topic, data collection and evaluation framework for local energy systems. I'll also present the work done by me so far. So, let us move on. Power systems engineering is a subfield of electrical engineering that deals with the generation, transmission, distribution and utilization of electrical power and the electrical equipment attached to it. This area of engineering is well explored by both scientific research and practitioner communities. To set the context of my research, let us briefly touch base on the abstract representation of power systems engineering process. Traditionally, electricity is generated from source like nuclear, thermal or fossil fuels. From generating power plants, the frequency of produced electricity will be stepped up and will be dispatched to the high frequency transmission networks that are represented in orange color here. From transmission networks, substations of several capacities get the input and will step down the frequency of electricity using stationed or pole mount transformers to supply the resultant low voltage electricity to feeder lines. Finally, loads are connected to low voltage radial feeder lines via three-phase or single-phase lateral feeder lines. However, this established power systems engineering process is undergoing some inevitable and fundamental changes. Let us see what are those changes. As you can see in the left hand side picture, cooling towers of a closed nuclear power plant are being demolished in Philipsburg, Germany. Germany plans to close all nuclear power plants by 2022. Likewise, many countries, as shown in the picture right, are preferring generating and consuming renewable based electricity over the traditional ones because of many reasons. Environmental and security are being the main ones. As per the International Energy Agency publications, by 2018, the share of renewables in global electricity production is 26%, and it is estimated to increase further as shown in the picture on the right. The renewable based production capacity from solar energy would be more than 850 gigawatts. The renewable based energy production can be done either at large scale using means like solar farms, wind farms, biomass or geothermal sources that can be connected to the transmission networks directly as an additional source, or using distributed energy resources DERs that are spread across low voltage networks. Let us see what is a DER and how it functions. A DER is a distributed energy resource. In an LVDN, it could be a normal load to start with. As a renewable energy source, for example, solar or wind as shown here is available, the DER starts producing electricity from it and can be self-sustainable, meaning that it will not draw electricity from the existing source anymore. As the production progresses, the DER could be a renewable energy supplier, providing its excess production to other loads. This phenomenon is the fundamental change to the structure and operation of low voltage distribution networks. Understanding the effects of these changes is essential to model and structure the LVDN properly and to maintain it in a safe operational state. The presence of active DERs are evolving LVDNs towards more decentralized and active networks. Large amounts of data arise from these active networks. Typical sources of data are electrical equipment like transformers, capacitors, lines, regulators, etc., or electrical parameters like voltage, active power, reactive power, resistance, reactance, etc., or renewable energy production establishment related data like irradiance, power factor, PMPP, inverter details, etc., or data pertaining to loads like demand profiles or effect of renewable generation on the loads. Utilizing these datasets is an essential step for developing future sustainable local energy systems. How then these datasets should be stored and shared? This is the main focus of my research. So let us see the important characteristics of the data emerging from these local energy systems. The datasets within the energy systems are multifaceted, interrelated. Another important characteristics of the data is it is immutable. Once created, the data cannot be altered. As Pat Halland calls in his work, immutability changes everything. This data is the data on the outside. That is, the data originates from a service and or from a device and is immutable by nature, semi-structured, has identity and may be versioned. Apparently, these unique features of datasets demands a special way of modeling and storing. I'll explain my plans on how to achieve this goal by starting with the experiments I did in this direction. As an initial step, I started with checking whether established data models like relational and NoSQL data models are suitable for modeling and storing this data. I used the datasets provided by OpenLV, which are taken from several distribution substations. First, I used the relational model to model the data in the datasets and store the resultant relations in MySQL database. Important drawbacks of this approach are the time to execute the join statements while executing the huge amount of data from various relations and modeling the transaction tables. Then as a second attempt, I used an in-memory database called Redis to reduce the read latency times. However, modeling the data is not smooth in this case either, as Redis is a key value store and converting the high frequency time series data to key value combination is not straightforward. Moreover, databases are centralized and the changes to the data are not transparent. Storing immutable data in these centralized databases is not reliable. Hence, to provide a reliable way of collecting, storing, sharing, and analyzing local energy systems data, I propose to use newly emerging distributed ledger technology. I will work towards developing a middleware-like platform over distributed ledgers, which would aim to provide a reliable data storage solution for immutable energy datasets, while also maintaining the relationships between the data steps and addressing the read-write latencies and scalability problems of the distributed ledgers. To achieve this above said research aim, a stepwise approach along with the appropriate research questions and a number of pre-development tasks are identified. The research questions identified are: what are the technical details of available distributed ledger platforms and what is their applicability in several domains? And second question is how the power systems are designed and what are the data sources in the power systems. It is important to know the general working of power systems and to identify more details about the data source. Final question is how to explore several existing solutions in this direction and how to prototype the technical solution. As I am progressing towards the second year of my PhD, let us see what is the progress I made in this year towards reaching these research goals. An extensive literature review is done on blockchain variants available and their applicability in different domains. The intention of doing the literature review is to observe how blockchains are used as a data storage solution in different applications. I created a structured literature review report based on the work which would be published separately. Also, the technical details of the power systems like architectural details, abstract representation, data sources, and effects of renewable sources in the power systems are identified. Here also, I created a set of algorithms and a tool implementing those algorithms to create a graph representation of low voltage network and to find the effect of PV on the loads in the low voltage network in the context of peer-to-peer trading. Here also, I would publish this results separately in a paper. After doing some groundwork to establish a foundation, the next steps in achieving the research goals are to identify the technical solutions for the middleware and to identify the data models for local energy systems data. I would welcome any feedback or suggestions. And now I am open for questions. Thank you very much for listening.